Today I'm going to summarize all of the AI agent content online, literally. OpenAI guide to building AI agents, Anthropic, Google, Microsoft, and I will add my own thoughts into it. Keeping up with the space is incredibly difficult, and there are guides dropping in every day. Well, guess what? No more FOMO after this video because I've done it all for you. I've worked with thousands of clients on AI agent applications, so I will add my own experiences so everything will make more sense. And no, I won't share a silly example of an AI agent that books my vacation. No one is excited about that, apart from me. But real business problems is what I will talk about. By the end of this video, you'll know more about AI agents than 99% of people, and I'll share the PDF that summarizes everything very nicely. So let's dive in. And let's start with agents foundations. What's the definition of an AI agent? Every company defines it in its own terms, but we can summarize it into a succinct definition of an application that uses an LLM to make decisions on what actions to take. Every application has a series of actions to take. Otherwise, we wouldn't really call it an application. We would call it a static website. But instead of humans making these decisions on what actions to take, AI would take them. And it's important to distinguish between workflows and true AI agents. Workflows are predefined paths. Even though you're using an AI model in that path, you still know exactly what the path or the flow is. So at Microsoft, most of the businesses we work with actually implement workflows. So for example, we built a returns approval agent for one of our clients where we used an AI model to make more nuanced decisions on whether to approve a return or not, like scanning the customer's return history, which uses an AI, and if the customer made a third return in under a month, which was detected by the AI, that would be flagged. So this is an example of a decision that would normally require a human to intervene, but AI did that. Agents, on the other hand, are more autonomous, so the workflows aren't predictable. An example of that is the deep researcher that's used in ChatGPT. What happens is that it searches the web, it gets results, it reasons on the results, and only stops when it decides it has sufficient information. Another example is Lovable or Replit, where you simply ask it to build an end-to-end application with a simple prompt, and the agent takes the prompt, builds the application, writes the code, performs tests, and only gives back the application once it decides that it has met your requirements. So that's an example of a more autonomous type of agent. Very important to distinguish between both. So here are some examples. I've already shared a few. Customer support is probably the most popular use case. So you can have a customer support agent that can understand customer requests, look up troubleshooting guides, ticket history, and provide a response. Refund approval is another example which I've shared previously. Deep researcher is another example as well. Coding agents like Claude Code are an example of very sophisticated autonomous AI agents. So they have access to actions like web search, updating your code base, etc., etc. And a very important decision to make and keep in mind is when to build an AI agent. OpenAI, Anthropic, and Microsoft each have their own recommendations. I really like OpenAI's one, which says AI agents make sense in scenarios with complex decision-making, where you cannot capture the workflow by a series of if-else statements using traditional automation methods. And number two is when the rule-based system that you have using traditional automation becomes difficult to manage. And number three is you are relying on unstructured data like scanning emails or documents, which are hard to parse with traditional methods. Anthropic says that you need to keep in mind that agents trade latency and cost for better task performance. If you think about it, agents typically use reasoning models to make more complex decisions, and they rely on tools as well. All of these cost money and latency. So really think about making these trade-offs. Microsoft, on the other hand, recommends building AI agents for open-ended problems, multi-step processes, and tasks that improve over time. Because ideally, we want agents to have learning memory so they improve with time. I'll talk more about that later on. Then we get into agents building blocks, starting with the model. This is primarily around picking the right model. OpenAI and Google talk about that in their white paper. So the first thing to think about is the task. Not every task requires an LLM. Think about SLMs for simple tasks like classification, or even a router that routes more complex tasks to LLM and less complex tasks to SLMs. And number two is refining models for the agent task by showing it examples of using specific tools in various contexts. This is something that Google recommends. And number three is to start with your most capable model. So establish a performance baseline with your most capable model, and then try and swap in that with smaller and more cost-effective models while still maintaining the performance baseline. The second building block is tools. There are three types of tools. Number one is actions. This is custom code functions including APIs. Number two is data, which are vector databases like RAG, operational databases such as SQL. And number three is agents. Another agent can be a tool call. And there are tools best practices as well. OpenAI recommends to have clear description. When you define your tools in your code, make sure they're described very well, because the LLM will use that description to understand what the tool does, and you have to be as clear as possible to avoid tool overlaps or confusions. And Microsoft also recommends to be aware of security threats like SQL injections, where someone can use a prompt to inject SQL commands into your database. And the common best practice to configure the app to have only read permissions. And finally, the last agent building block that not a lot of people talk about, and I didn't get it from these white papers, but I still think it's important to mention, and that is state. State is different than memory, which we'll get into later on, but state is a way to track information as the AI agent processes data in a workflow. It's like RAM. Remember, agents are typically multi-step processes, and they handle data along the way. That's what they are. And these data can be tracking what tools were called, what messages were exchanged with the user, etc. Deep Researcher is a perfect example, because you often get the question from the user, and that based on the question, you generate maybe a research brief, which is stored in a state or a variable. That brief is used by another supervisor agent to delegate the research to different specialized agents. Each specialized agent produces a report stored in state or another variable that then a research compiler would use to write the final report that is also stored in a state or a variable before being surfaced to the end user. Everything is managed by states and variables. Very, very, very important point to take into consideration. Next, we get into agent orchestration. Starting with instructions. Needless to say, you need to make sure that you have high quality instructions, typically by system prompts. OpenAI recommends leveraging existing documents like customer service procedures or standard operating procedures. So if you have these in your businesses, make sure you leverage them when you're conducting your system prompts. Number 2 is make sure that you have clear actions. Number 3 is smaller and clearer steps work a lot better. And last but not least, make sure you're capturing edge cases in your AI agents via system prompt instructions. Microsoft recommends templating your system prompts. So instead of manually writing each system prompt from scratch, you can just create like a meta prompt that teaches an LLM how to write a good system prompt for you. Save you a lot of time. Anthropic says, put yourself in the model's shoes. Is it obvious how to use this tool based on the description and the parameters? Or would you need to actually think carefully before using these tools? I like that frame of reference, actually. Next is memory. Again, this is a section not heavily emphasized in these white papers, but I'm giving you extra content here, which I definitely think is relevant. Not many people talk about memory, and in specific, that there are different types of memory. I made an entire video about that. So, there are 3 types of memory. Number 1 is semantic memory. This is when agents store factual information, like user preferences, domain-specific information, like supply details, etc. All of them are typically stored in a vector database. Second type of memory is episodic memory. This is when agents remember past actions and experiences. So instead of just knowing facts, the agent can record past experiences. An example is an agent saying, I remember when handling an urgent laptop order, I successfully negotiated a 2-day delivery window by mentioning our history of bulk purchase. And practically, this is implemented by storing few-shot prompts or examples in a vector database. So that storage actually happens dynamically. For example, when you get user feedback that are marked as positive, we automatically store that as few-shot prompts in a vector database that are retrieved at the right time. So this is an example of episodic memory. Another thing is procedural memory. This is when agents improve with user feedback. So the agent doesn't just remember what happened, it also gets better at following instructions and performing tasks. Practically, and I do want to keep this practical, this happens when you're storing system prompts in a vector database. So what happens is that the user feedback on how the agent should behave is parsed into a system prompt and stored in a vector database. So we're dynamically updating the system prompt based on user feedback. Very powerful. This is what we call self-learning AI agents. And the last element of agent orchestration is reasoning. We've heard a lot about LLM reasoning, and the primary way to trigger these reasoning chains is by prompting them the right way. And keep in mind that when you're using reasoning models like GPT-o3 or GPT thinking models, all of them actually have these prompts implemented behind the scenes, so you don't have to worry about them a lot. But it's important to keep these reasoning prompts in mind. Google advises these 3 main prompt engineering techniques. The first is called REACT, which reasons on the problem to take actions in an iterative cycle until the task is complete. We spoke about that when I explained autonomous agents. Number 2 is chain of thought. This is prompting the LLM to work through the problem step by step by showing its reasoning process before arriving at the final answer. Most reasoning models do that out of the box. Number 3 is tree of thought. This is when the LLM explores multiple reasoning paths at the same time and compares the different approaches before selecting the final or best path. And next we're going to get into agent architectures. Firstly, single versus multi-agent. OpenAI recommends maximizing single agents capabilities first because more agents, yes, can provide better quality responses, but they introduce additional complexity. So the question is, when to go multi-agent. Number one, when you have a complex logic. So when your prompts or system prompts contain many conditional statements like if-else statements, that is when you have to think about building multiple agents. So it is very powerful when you have a specific system prompt for each agent. Yes, you can use prompt templates to do that, but when the prompt becomes too long and you have too many conditional statements, that's when you think about using multiple agents. And number two, probably the most important reason, is when you have tool overlay. And that's not just the number of tools, which is important, but the similarity or overlap of these tools, because the model would get confused on what tool to use. And last but not least is different expertise, like having different research agents as an example. This is an example that Microsoft mentions. And when it comes to multi-agent architectures, here are different examples of architectures. Anthropic does the best job explaining all of them. Highly recommend checking out their article, but I'll summarize each one. The first example is prompt chaining. This is when you run agents sequentially. The perfect and most common example is a data processing pipeline. So it goes from data capture, cleansing, transformation. That is a pipeline. Another example could be a marketing copyright that goes through multiple departments like products, legal, etc. The second agent architecture is called parallelization, and this is when you run multiple agents in parallel. Any type of researcher agent is a good example because you typically need multiple researchers running in parallel. Research is a big use case for AI agents. Like I work with lots of pharma and health companies that rely on a lot of these use cases because a big portion of the work is research, and they need to build domain-specific AI agents that can perform more complex research tasks rather than use one out of the box by these providers. So it could be analyzing also customer reviews where each LLM or agent focuses on a specific element. So these are all examples of parallelization. Next, we get into routing. And this is when you have an LLM that classifies the request and routes it to the most appropriate agent or LLM. The most common example is routing simple tasks to smaller models and more complex tasks to reasoning models, which are more expensive. Last but not least is the orchestration architecture. And this is when you have a supervisor type agent that orchestrates calls to multiple agents, and then you have a synthesizer which compiles all of the results out. Next, we get into agent frameworks. I made an entire video about that, so make sure to check it out. Anthropic actually recommends not to start with agent frameworks, but instead calling the APIs directly. And I actually agree with that, because a lot of times when you use the agent frameworks, and again, I did an entire video about that, they abstract many things, which means that when things go wrong, you would have no clue what's happening behind the scenes. So only use these frameworks when it's warranted, and that's typically for multi-agentic systems. So Microsoft actually highlights these benefits of using these frameworks. Number one is when you need agent collaboration. So in multi-agent systems, you need agents that can work together, and these frameworks make it very easy. And number two is when managing a lot of context. So frameworks makes managing context and state a lot easier. And the most popular frameworks right now are LangGraph, which is the production-ready version of LangChain with less abstractions and more control. Number two, Semantic Kernel, which is Microsoft's AI framework, where it is open source and trusted by a lot of the large enterprises. Number three is AI SDK by Vercel, which is very popular amongst JavaScript developers, very loved by the community. Of course, there are tons of others. I just wanted to highlight these three. And then we get into communication protocols. So as AI agents explode, we need standardization in communication protocols that ensures security and open innovation. Similar to how we had standardized communication protocols like HTTP to access APIs, we need standardized protocol to access tools, which is what MCP does. A2A actually takes us a step further by standardizing communication between AI agents. So let's take a step back. With MCP, it is basically a standardized way to access tools exposed by AI agents, similar to how we use an API or HTTP request to access functionality by other providers in a standardized way. MCP is the same, but for tools. So instead of hooking up APIs to different providers to connect to their tools, you just connect to an MCP endpoint that they expose, and they handle all of the tool descriptions, integrations, system prompts, etc. You don't have to worry about that. Agent-to-agent communication is a way to standardize communication between agents, because a lot of these multi-agentic systems actually involve communicating between different agents. So you need a standardized way to access tools and a standardized way to access agents. And the last section in this video is agents in production, starting with guardrails. Needless to say, AI agents that are running in production need to have guardrails. OpenAI talks a lot about that in detail, and they're boiled down into number one, safety. So this is making sure that you are protecting against prompt injections, jailbreaking, etc. Typically, another LLM runs side by side that is trained on spotting these things is used. Number two is PII filters. So if you're dealing with sensitive information, they need to be classified and filtered. Number three is moderation. So this is protection against violence, hate, etc. Again, another LLM is typically used that is trained on these things. Number four is tool safeguards. So that's making sure that you put guardrails on tools. And for example, could be the max amount of time that a specific tool is called, especially if AI agents are autonomous, otherwise they will run into endless loops. Last but not least is output validation. So does the output, for example, match your brand guidelines? This is an example of an output validation. Another important topic is observability. And in general, observability is a measure of how well we understand the system from the outside looking in. AI agents are complex, multi-process with lots of components. So observing how they operate can be a challenge. And fundamentally in AI agents, we have traces, which represent a complete agent task from start to finish, and there are spans, which represent a specific task. So you typically have to monitor both of these things. And the key metrics to track are, number one, latency. So how quickly does the agent respond? So individual steps and entire traces is applied to that. Can you use a faster model or running model codes in parallel to account for that? Number two is costs, and that is per agent run. Frequent tool calls or multiple LLM calls can be costly. Are these justified? And number three, of course, is errors. This can include LLM API errors or failed tool calls. Number four is user feedback. Could be direct feedback, could be repeated queries or questions that user asked, many examples. OpenTelemetry is the industry standard for LLM observability. And what makes OpenTelemetry stand out is that it's vendor agnostic, which means that you're not tied down to any specific platform. You can gather your telemetry data and send it off to any destination. The last but not least is evaluations or EVADs. Evaluation is the process of analyzing all of that data and making the relevant changes. AI agents are non-deterministic, so evaluation is incredibly important. In fact, I spend 75% of my time evaluating my AI agents than writing code, because AI agents are non-deterministic. So there's a lot more effort in evaluations versus traditional machine learning systems. Microsoft outlines that there are two types of evaluations. Number one is offline evaluation. This is when you're evaluating an agent in a controlled setting and not live user queries. So you typically have a test dataset with questions and expected answers. So you perform tests, you gather data, and you make the relevant changes. The challenge is ensuring that your test dataset is comprehensive and reflects reality. Number two is online evaluation. This is when you're evaluating the agent in a live environment based on real user interactions. So you need to track things like success rates, user satisfaction scores, and other live traffic, and more importantly, use that data to actually make changes in your agents. So that's pretty much the end of the video. Hope you found lots of value from it. Let me know your feedback in the comments. Thank you for your time.